So my previous video went through the top stuff. That is the explanation. That is the cause. That is the reason why we're going to see all of these patterns. So it's really important that we watch, understand, and like I said at the beginning and the end, we label our own periodic table with that. But this is important because it explains how things bond and how things react. So when an atom currently exists in its neutral state, it almost always doesn't have a full energy level. So it will either gain electrons to become full or it will lose electrons to become empty. What is going to determine what it does? It really has to do with, is it closer to being full or is it closer to being empty? But that connects to everything we just said about Zeph and shielding. The things with a very, very strong attraction have that strong attraction because of very small shielding and a lot of Zeph. That is what got them to be almost full, and that is what's going to make them gain electrons. When we have a very, very weak attraction, that corresponds to a very, very low Zeph, a very low number of valence electrons, and it's very easy to lose them. So here, the gain, lose, we can fill those in as just facts. But what we're going to be doing on the tests, on the quizzes, on the claim evidence reasoning is making that connection between the patterns, left, right, up, down, and how that attraction turns into the ability to gain or lose. So ionization energy and electronegativity were words that we defined at the beginning, but we need to bring those back. We should have those on our notes once. We should have those on our vocab sheet. But ionization energy is about losing an electron. Things which are likely to lose electrons do that because they aren't holding them very tightly. So here, ionization energy, the energy required to lose an electron. When we go left to right, because I have more Zeph, because I have more attraction, it gets harder and harder and harder. But when I go top to bottom, it becomes easier and easier and easier. Once again, we're thinking, how far is that electron away? The radius pattern really helps us to think about this pattern as well. So the impact on the attraction, or really in this case, as the other one, the connection to the attraction is when it's close, when it's strong, it's going to hold on to that electron really, really, really well. But when we have that big atom and that weak attraction, it's going to be easy to lose it. Electronegativity is the same idea with the opposite happening. Some elements lose electrons. Electronegativity is about how they gain electrons. So when we come over here, electronegativity is the energy associated with or the desire of an atom to gain that electron. As we go farther over, they want to gain a little bit more, a little bit more, a little bit more. That's because we've got more Zeph, we've got more positive charge, we've got more attraction for those. So we've kind of got our cause and our effect here. More attraction leads to more electronegativity, or more electronegativity comes from that more attraction. So that high attraction, remember that's really far to the right, really high up to the top, is going to have a really, really high electronegativity. Whereas those elements which are not as far to the right and not as close to the top are going to have a weaker attraction and therefore a weaker electronegativity. So what we're looking at right here is what kind of puts together the things that I just said. You see the completed version, but which of these things really, really help us to explain the why? What makes it easier for something to gain an electron as we go left to right, or what makes it easier to lose an electron as we go top to bottom? So think about the attraction left to right, think about the attraction top to bottom, and we're really going to go back to those patterns from the top. So you can pause. I'm not going to pause awkwardly. I'm just going to click over. So when we are going left to right, we've got more Zeph, which means more positive charge holding the electrons. The shielding stays the same. That doesn't have anything to do with how much we want to gain. The ionization energy does go up, but that's not about gaining electrons. The thing about gaining electrons is electronegativity. And that all connects because of that greater attraction associated with the smaller atoms. So we've got a smaller radius. So right here, this is our Y on the gain. More positive charge, more electronegativity in that smaller, more attractive atom. The top to bottom losing, well, our Zeph is the same top to bottom. That doesn't explain it. The electronegativity actually is going down, so that's not explaining it. The reason it becomes easy is those extra energy levels. Those extra energy levels make it the atom larger, and that larger atom connects right back to being easier to remove an electron. So these patterns right here are important ones, and we could, on our periodic table right here, we could look at or think about those as and here I have changed my colors. This shows my electronegativity pattern. We could think about what we know about radius, what we know about electronegativity as we go this way. More attraction, bigger electronegativity. As we go this way, more attraction, bigger electronegativity. So we're seeing the really here dark colors over here because they attract really well, whereas these don't. We could do the same thing with ionization energy. We could do the same thing with radius. So on your periodic table, we're going to do it on the back when we summarize it. But once again, make that a tool that's easy as possible to answer each question that you're ever asked on homework, on quizzes, and on labs.